welcome back. I really missed all of you. Uh, Good afternoon, Rishikesh, Avni, Nishi, Anushka, Anuj, Hitesh, Anagha. A very good afternoon to all of you. I hope you've started enjoying statistics now. And I think some parts of statistics, initial parts, you've already done in your class 12th also, those who are giving the 12th exams. And for the others, it is a very exciting chapters that have a lot of practical applicability. So statistics is something that is very intuitive. So always remember that in statistics, instead of mugging up those formula, it's better that you understand what the concepts are and then you will be able to apply it. Okay. Yes. So let us dive into this. So you've already studied about statistical description, then you've studied about probability. You know what are the concepts of mean, median, mode, standard deviation, variance. Okay. So, taking that topic, taking those concepts further, now we are going to dive into what is known as probability distributions. And in our syllabus, we have three main ones, that is binomial, Poisson, and normal distribution. Okay, and weightage wise, if you would like, I'll just let you know what is the weightage. Okay, so the chapter on probability theoretical distribution that we're going to do today. So these two comprise of 25 to 30% of our syllabus for statistics. Okay. So it's a like obviously it's a very important chapter. Okay. So let us go into it. Now you have already done about frequency distribution. So once if that concept is clear, this becomes easier to follow. If not, I would request you to just go back, just go through what the concept was, and then we could take it from further. Okay. So see, what is probability? It is just like distributing the total frequency in different class intervals. Okay, like we had this x and then we had f and then we did summation f, right? So similarly, we could have this. So the total probability, you know that probabilities P1, P2, etc. If you add them up, this should be equal to 1. Okay. So the total probability, that is 1, is distributed to different mass points in case of a discrete random variable or to different class intervals in case of continuous. So remember that if I have discrete, okay, so if I have discrete distribution, then what will happen is that I will be able to then different mass points. Okay. But when I have continuous distribution, what will happen? I have to talk about a range. Okay. So range, which is quite logical, right? Because we don't have one particular thing. So you're talking about a range. So such a probability distribution is known as theoretical. So why do I say it is theoretical? This is because it is something that we are calculating it, okay? And we have what is actually we can see and what we are calculating, that is theoretical. So we need to study the theoretical probability distribution for the following important points. The frequency distribution gives a number of times a data point occurs. So the frequency distribution that we have studied till now, what does it give us? It gives us a data point. Okay. Okay. So we know like if I'm talking about say 0 to 5, So number of students who got this mark. So then if that is equal to 3, it means that there are 3 students which have who have marks 0 to 5. But what does probability distribution gives you? It gives you the probability that this data point will occur. Okay. So whether or not this will occur is given by the probability distribution. Just a minute, I'm not able to see your questions. Just a minute. Okay. So then it is used to predict short-term projections for future. And third important thing is that it is possible on the basis of theoretical. So what analysis we do on the theoretical probability distribution. So what do? We set the confidence limits. Okay, this part of it, after we finish with the normal distribution, etc., it will become more clear. Right now, you need to understand that frequency distribution will give you the data points. Probability distribution will give you whether or not that data points will occur or not. And what is mm, what is the scope? We can use it for short-term projections. Okay. And the third thing is that once I set confidence limits, I can use statistical data analysis tools on this theoretical distribution to come about to know about the population. Okay. Now there are we are studying this. So binomial is discrete, Poisson is discrete, and then normal is continuous distribution. Okay. Now let us consider this example. Okay. Let us consider this example. I'm trying to tell you what the overall view is of these 3 distributions that we are going to study. So let us consider that you are analyzing a coffee shop. Okay. So in a coffee shop, there are many tables. Okay. And they will be giving orders while people are sitting on those tables. So let us consider a coffee shop and in which there is an average of 20 orders per hour. Okay. So it's a good coffee shop and the tables are usually full with 20 orders per hour. The orders are independent events. Okay, obviously, just because I am ordering, say maybe a latte, the table next need not order depending on my order. Okay, they can order independently, right? So the orders are independent. Okay. Then the standard deviation of the number of orders is 4. You remember standard deviation that you've already learned about? Okay. So what this in the rough sense means is that I have an order of 20, I have an average of 20 orders per hour. So it can fluctuate between say 16 to 24. Okay. That's just a way of saying it. Okay. So sometimes you may have 16 orders per hour, you may have 18 orders per hour, or you may have 22 orders per hour. Okay. So this is the basic thing that is that information we're trying to take an example and work out the meaning of these 3 distributions or what information I can get from these distributions. Okay. So I'm in a coffee shop. The average orders per hour is 20. Okay. With a standard deviation of say 4. Okay. These are all random figures. So what happens if I use the Poisson distribution? Okay, so what will the Poisson distribution help us? It will help us to model the probability of a specific number of orders in a given hour. Okay. For example, if I want to find out how probability of getting 15 orders, then I will use the Poisson distribution. Okay. Then what will the normal distribution give us? The normal distribution helps us model the probability of a range of orders in a given hour. So if I want to find out whether what is the probability of getting at least 15 to 25 orders, okay, then if I want to make any like maybe marketing strategies or this thing, for that I require this kind of information. How many orders, what is the probability that I'll get orders between 15 to 25? For that, I should use the normal distribution. Okay. And the third is the binomial distribution, which we are going to study today. It helps us to model the probability of a specific number of orders in a randomly selected time frame. Okay. Here, what we wanted was specific number of orders. Here, I'm selecting the time period and I want to know whether or not I will get a specific number of orders. Okay, so any maybe I select a half an hour slot and I want to know whether or not I get 15 orders in that half an hour slot. Okay. Yes, now this is working. Okay. Good afternoon, Preeti, Anuj, Priyanka, Nancy, Kinjal, sorry, Sunil, Khushi, Sejal, Ashika, Kritika, Dheeraj, Sakshi, Renuka. Yes, thank you, Renuka, for welcoming me back. Ashinka, Laksha, Sakshi, Tambeshwari. Yes. Okay. The study material also. Now, there are few words that you find in statistics. Okay, those terminology. I'm just trying to explain those. Okay, sometimes you'll be seeing that probability mass function, probability density function words are used. So when I'm talking about the probability mass function, it is a concept used in probability theory to describe the probability distribution of a discrete. Okay, so this is talking about discrete. Okay. For a discrete random variable, the PMF gives the probability that the variable takes on a specific value. Okay. For continuous, we use the usually use probability density function. Okay. Now we are moving towards the binomial distribution that we have today. Okay. Now, what this binomial is based on Bernoulli's trials. Okay, what is Bernoulli's trials is that I am trying to do an experiment. The experiment is such that the events are independent. They are identical, like tossing of a coin. Okay, flipping of a coin or tossing of a die. So then they are identical and they are identically distributed. That means that it is an unbiased dice, unbiased coin. What are the outcomes? Outcomes are 0 or 1. That is either a success or a failure. Like suppose I say in case of coin, so getting a heads may be a success. Then obviously getting a tail will be a failure. Okay. It is a discrete time stochastic. Okay. So the word stochastic also appears so many times. So sometimes it is called as stochastic also. Okay, so stochastic is also the pronunciation. So it is random, can't be predicted, probability is inverse. So anytime when I don't know the outcome, I say it is stochastic process. Okay, so when I did this experiment, say maybe flipping off the coin 10 times, I know that it is independent, and getting a head or a tail in the second attempt, second time I flip a coil, is independent of whether I got a head or a tail first time. Okay, so all events are independent. They are identically distributed. Okay, so there is no other changes. Okay, I haven't kept a magnet, or I haven't, like, the environment is also the same. Outcomes is 0 or 1. Either I get a heads or a not. And then it is discrete time. Okay, so 10 times I can flip a coin, say maybe. Then the binomial distribution is an extension of the concept of the Bernoulli's trials to describe the number of successes in a fixed number of such trials. Why am I telling you? Because even though it is not written in front, but in the MCQ, you have a question on Bernoulli. So I have explained the Bernoulli also. It provides a framework for analyzing and calculating probabilities associated with multiple Bernoulli trials. Okay. So these are the things you need to know. Okay. Yes, Hitesh understood. Sonam, good afternoon. Yes. Now let me tell you in Hindi also. ये जो बर्नौली का ये जो प्रोबेबिलिटी डिस्ट्रीब्यूशंस है वो आपके फ्रीक्वेंसी डिस्ट्रीब्यूशन जैसे हैं, जिस तरह उस वहां पे आपका एक कॉलम एक्स का होता था और एक कॉलम एफ का होता था फ्रीक्वेंसी का, उसी तरह से यहाँ पे भी है। यहाँ पे आपकी प्रोबेबिलिटी का एक कॉलम है। इसमें हम तीन टाइप के प्रोबेबिलिटी डिस्ट्रीब्यूशन से हम लोग उसके बारे में बात कर रहे हैं। दो पहला है बाइनोमियल जो आज हम पढ़ने वाले हैं, फिर पॉइसन है, और फिर उसके बाद है नॉर्मल डिस्ट्रीब्यूशन। जो बाइनोमियल और पॉइजन है वो डिस्क्रीट है। डिस्क्रीट माने जो आप मेजर कर सकते हैं डायरेक्टली। तो वो और जो नॉर्मल है वो कंटिन्यूस डिस्ट्रीब्यूशन में पड़ता है। जैसे आपका हाइट है, तो हाइट कैसे आप उस समय आप रेंज के बारे में बात करते हो। आप किसी को ये नहीं सोचते ना, आप पूछेंगे कि 5 से 5.5 फुट हाइट के कितने बच्चे हैं। आप ये नहीं बोलोगे ना 5 फुट 1.2 इंचेस, ऐसे नहीं बोलते ना। और नॉर्मल एक रेंज हम बताते हैं, उस हिसाब से उसमें आता है वजन के बारे में, हाइट के बारे में, मतलब ऊंचाई के बारे में आप जब बात करते हैं तो आप उस तरह से बात करते हैं। ओके, तो ये हम लोग डिस्ट्रीब्यूशंस हम लोग पढ़ने की कोशिश कर रहे हैं, और उसमें हम समझने की कोशिश कर रहे हैं कि उसमें किस तरह से हम उसमें जा सकते हैं। उसमें हमने ये बताया, जैसे हमने कॉफी शॉप के बारे में बात की कि जिस कॉफी शॉप में 20 टेबल्स पे ऑर्डर्स आते हैं एक घंटे में, तो उसमें अगर हम पॉइजन में हम क्या करते हैं कि हमें अगर समझना चाहते हैं कि 15 ऑर्डर्स का कितनी प्रोबेबिलिटी है, कितनी प्रोबेबिलिटी है कि 15 ऑर्डर्स हमें मिले, तो हम पॉइजन यूज करते हैं। नॉर्मल में हम कैसे एक रेंज बताते हैं, 15 से 20, 15 से 25 ऑर्डर्स हमें मिल सकते हैं, उसकी प्रोबेबिलिटी क्या है। और उसके बाद बाइनोमियल में हम बोलते हैं कि इस पर्टिकुलर घंटे में हमें 15 ऑर्डर्स मिलेंगे क्या, अगर हमें वो ढूंढना है तो हम बाइनोमियल की ओर जाते हैं। तो कौन सा डिस्ट्रीब्यूशन कब यूज करना है, इसका ये एक बैकग्राउंड है, इसका एक आपको समझ आए इसलिए बताया गया है। ठीक है। उसके बाद हम आज जो बाइनोमियल के बारे में बात करें, उसका बेस जो है वो बर्नौली ट्रायल्स से है। बर्नौली व्यक्ति का नाम है, और उन मतलब क्या बोल रहे हैं कि हम जो ट्रायल्स है, हम जो इवेंट्स है, तो वो इंडिपेंडेंट है। माने जैसे हम अगर सिक्का उछाल रहे हैं, तो अगर हम 10 बार सिक्का उछाल रहे हैं, तो अगर मेरा जो दूसरी बार हमारा हेड्स या टेल्स आता है, तो उसका पहले वाले से कोई लेना देना नहीं। पहला क्या आया था उससे हमारा अभी का जो रिजल्ट है उस पर डिपेंडेंट नहीं है। ओके, आई होप यू ऑल अंडरस्टूड। देन देर इज दिस ऑल्सो कॉन्सेप्ट ऑफ, सो हम क्या बोल रहे हैं कि द बाइनोमियल डिस्ट्रीब्यूशन इज एन एक्सटेंशन ऑफ द कॉन्सेप्ट ऑफ बर्नौली टू डिस्क्राइब सच द नंबर ऑफ सक्सेसेस इन अ फिक्स नंबर ऑफ ट्रायल्स. It provides a framework for analyzing and calculating probabilities. Okay, analyzing and calculating probabilities. एक और कॉन्सेप्ट है, मतलब पहले प्रोबेबिलिटी मास डिस्ट्रीब्यूशन और ये हो गया। अब स्क्यूनेस, हमने बहुत बार क्वेश्चंस देखते हैं ना, इज इट राइट स्क्यूड, पॉजिटिवली स्क्यूड, नेगेटिवली स्क्यूड। स्क्यूड क्या होता है? स्क्यूनेस इज अ मेजर ऑफ एसिमेट्री ऑफ अ प्रोबेबिलिटी डिस्ट्रीब्यूशन। सिमेट्री आप सबको मालूम है कि जैसे हम ह्यूमन बॉडी सिमेट्रिक है, दो अगर बीच में से लाइन ड्रॉ करें तो मतलब हम इक्वली डिवाइड कर सकते हैं अपने बॉडी को। तो स्क्यूनेस इज अ मेजर ऑफ एसिमेट्री, मतलब जो सिमेट्री नहीं है ऑफ अ प्रोबेबिलिटी डिस्ट्रीब्यूशन। पॉजिटिवली स्क्यूड मींस टेल इज टू द राइट। ऐसा जब होता है, ये इसको ना टेल बोलते हैं। तो अगर हमारा जो टेल है वो राइट हैंड साइड को जा रहा है, तो उसका मतलब उसको पॉजिटिवली स्क्यूड बोलते हैं। फॉर अ बाइनोमियल डिस्ट्रीब्यूशन, स्क्यूनेस कैन बी इन्फ्लुएंस्ड बाय बोथ द नंबर ऑफ ट्रायल्स एंड द प्रोबेबिलिटी ऑफ सक्सेस। मतलब ये भी थियोरेटिकल क्वेश्चन आ सकता है कि वेदर skewness of binomial is independent or is it dependent on certain things. So yes, the symmetry or the skewness of a binomial distribution is dependent on the number of trials n and the probability of success p. Okay. हाँ अनुज, समझ में आ गया? गुड गुड, ठीक है। आपको कभी भी लगे कि आपको नहीं इंग्लिश वाला समझ में आ रहा है तो आप बता दीजिए, उतना मैं हिंदी में बता दूंगी, जितनी मुझे हिंदी आती है। क्योंकि ये जो टेक्निकल टर्म्स है ना, उसका उसका हिंदी शब्द शायद मुझे मालूम ना हो, तो उसके लिए मैं भी माफी मांग लेती हूँ। ओके यस अनुज, बिल्कुल सही। डिस्क्रीट में बाइनोमियल और पॉइजन है, और कंटिन्यूअस में हम नॉर्मल डिस्ट्रीब्यूशन बात करें। व्हाट आर द फीचर्स ऑफ बाइनोमियल डिस्ट्रीब्यूशन? मतलब कैसा उसको हम डिफाइन करने के लिए क्या क्या यूज करते हैं? हम बोलते हैं कि ईच ट्रायल हर इवेंट जो है वो टू म्यूचुअली एक्सक्लूसिव एग्जॉस्टिव आउटकम्स। मियाओ। म्यूचुअली एक्सक्लूसिव मतलब एक एक जो उसका आउटकम है वो दूसरे पर डिपेंडेंट नहीं है, तो एक्सक्लूसिव है। और एग्जॉस्टिव है मतलब दो ही आउटकम हो सकते हैं, या तो सक्सेस या फेलियर। मतलब जैसे टॉसिंग ऑफ कॉइन, सिक्का जब उछालते हैं तो या तो सर आएगा या नहीं आएगा ना, तो हेड्स आएगा या टेल्स आएगा। तो इस उस हिसाब से एग्जॉस्टिव, एग्जॉस्टिव मतलब उसके बाद और कुछ हो नहीं सकता। इन दो, ये दो पर्याय हैं हमारे पास। द अकरेंस ऑफ वन ऑफ विच इज नोन एज सक्सेस। किसको सक्सेस बोलना है वो हम डिफाइन कर सकते हैं। मेरे लिए टेल्स सक्सेस हो सकता है, ठीक है, तो उस समय टेल्स को हम सक्सेस में बोलेंगे। ओके। एंड नॉन अकरेंस इज नोन एज फेलियर। So when a coin is tossed, usually the occurrence of a head is known as success, and non-occurrence is known as a tail, is known as a failure. The trials are independent. Okay, so कोई influence नहीं है, independently आप वो experiment कर सक रहे हो. The probability of success. So success is denoted by P, and Q जो होता है उसको failure. Always remember P plus Q is always equal to 1. This is something that you must remember. So you can write P as equal to 1 minus Q, or you can write Q as equal to 1 minus P. Okay. So this is important. Suraj, yes. Onkar, good afternoon. Once I start in another languages, then everybody is going to say I'll have a good, I'll have to learn all the Indian languages then. Yes. Okay, so the number of trials is finite positive integer. Okay, this is also very important. Just remember, कभी कभी आप कैलकुलेट करते हो और एन आपका नेगेटिव आ जाता है, तो ऐसा तो नहीं चलेगा, इसका मतलब कैलकुलेशन एरर है। ठीक है, so you must have n number of trials, n is positive finite. Probability you already know, it cannot be less than 0. It can be max, the lowest can be 0. Okay. Now there are n independent trials. Okay. So summarizing, there are n independent trials. Each trial can result in either a success or a failure, only one of the two possible. So what we do, probability of success where p is constant from trial to trial, and p of failure is 1 minus p. X represents the number of successes in the trial. Okay, so this is all, we're just trying to summarize. Now, where do I apply binomial? Binomial distribution is applicable when the trials are independent and each trial has just two outcomes, success or failure. It is applied to coin tossing experiment, sampling inspection plan. So when I'm trying to inspection, either there is there is an error, or there is an aberration or not. Okay, and genetic experiments and so on. Okay. Now let us go to some questions. So now what is it? What do you mean by trial? See, I've picked up questions from study material, so that becomes easier for you. A trial is an attempt to make something possible. That is the English, right? I try to make, maybe I try to bake a cake. Okay, so make something possible. That is the English language. But what we want here is the definition in statistics. Make something impossible. This is obviously not the aim. Prosecute an offender in a court of okay. So this is my English, this is my law, and this is not possible. Produce an outcome which is neither certain nor impossible. So this is a very important phrase, neither certain nor if it is certain, then it is not a trial, it is a fact. Okay. And is it impossible? No, we are going to only try to do within the trial something which is possible. Okay, so 7D is the correct answer. So that is why sometimes, students learn all those formulae and then still they don't do well in statistics comparatively. Why? Because they have not paid attention to the theoretical aspects. So it's a lot scoring, just to understand the concept and try to implement those concepts. Once you've understood, you don't have to learn anything. Okay, you don't have to learn what is a trial, you already know it. Okay, so you can quickly put the correct answer. The important characteristics of Bernoulli trial. So we did just now Bernoulli. Okay. It is independent, identically distributed. Outcomes are 0 or 1. It is discrete time stochastic process. So what are the important characteristics? Each trial is associated with just two possible outcomes. Correct. Trials are independent. Correct. Trials are infinite. No. We are talking of finite things. So both A and D, yes, this is the correct. So for 8, D is the correct answer. Now coming to the actual formula for binomial distribution. A discrete random variable x is defined to follow the binomial distributions with parameters n and p and is denoted by x, b, and p. This b stands for binomial. If the probability mass function of x is given by, okay, so this. So what is the formula for finding the probability? So p will be probability mass x equal to x is given by ncx p raised to x q raised to n minus x for x having the value 0, 1, 2, 3, etc. up to n. And this is equal to 0 for otherwise. Okay. What does this mean is that this is implying that it is discrete. Okay. So if I have, say, x to be equal to 1.3, then the value of the probability mass function will be 0. Okay. So this means in some books, like if you're referring to some other, NCR also is also possible. And here we are using x. Okay. So it should not make a difference. It's just a way to. Yes. Kritika Kinjal. Yes. Anuj. Yes. Priyanka also. Very good. Very good. Now the ninth question. The probability mass function of a binomial distribution is given by. Whenever you have such formula, this is an important tip. What you do is quickly, just write down NCX, P raised to X, Q raised to N minus X. Because sometimes what happens while reading through, I may make a mistake. Now NCX. So obviously this is not possible. Okay. Because it does not have NCX. Then this has NCX, yes. P raised to x, q raised to n minus x. So This is the correct answer. Why the next one C not correct? Because Q raised to X. We need P raised to X. Okay. So technically, like if I make the calculation also, this is instead of P, it is written Q. And here, so here and here, this should be raised to X and not N minus X. Now the next question, 10th question. If X is a binomial variable parameters N and P, then X can assume any value between 0 and N, any value between 0 and N, both inclusive. See, this is again very important that you pay attention. Okay, so here what is they using the word value, and here any whole number between 0 and n, both inclusive, and any number between 0 and infinity. So this infinity, we are talking of measurable numbers. So this option is already gone. Now 1, 2, 3, ABC, any value or any whole number. Okay. That is why you must pay attention to the theory, because actually speaking, B is also correct. Just like when you're in such a hurry to quickly tick mark, you will say any value between 0 and n, any value between 0 and n, both inclusive. Yeah, answer. But that does not happen. Any whole number between 0 and n. Why? Because we are talking about discrete distribution, and in the formula also you know that X can take the values 0, 1, 2 up to n, and the probability mass function value is equal to 0 otherwise. Okay, this can fetch you 1 mark here, 2 marks here. Okay, understood? Kinjal, 0 for otherwise means it can be 0 means it is 0, not it can be. It is 0 when your X is not a whole number. Okay. Yes, Anushka, correct. So C is the correct answer. So just revising, when I'm talking about binomial distribution, I'm talking about independent trials. Okay. Outcomes are success or failure. Okay. What is the formula? NCX P raised to X Q raised to N minus X. Okay, where for X is equal to 0, 1, 2 up to N, and is equal to 0 otherwise. Okay. And important thing to remember is P plus Q is equal to 1. Okay. So what we are doing, we are studying probability distribution. In the probability distribution, you have the discrete distribution and you have the continuous distribution. So the discrete distribution, again, we are going to talk about the binomial distribution and the Poisson distribution. In continuous, we are going to talk about the normal distribution. Okay. So this is what we have done till now. Now let us dive more deep into what is binomial distribution. Okay. So I've already written it is an important theory. Yes, understood. Anushka, parameter means what? Parameter is the characteristics we are trying to study. Parameter is the characteristic we are trying to study. Okay. Now, as n is greater than 0, p and q greater than or equal to 0, it follows that fx is greater than or equal to 0 for every x. Okay. Now, n is greater than 0. Why we have not taken n is equal to 0? That means there is no experiment. So, then it is of no point trying to study. N is greater than 0. So, 1 and above. Then only we have to study. What this means is that the summation fx will be for each independent trial. Okay, each independent trial if I do, and then if I add them up, that should be equal to 1. Okay, this probability that I get for all, when I add them up, it should be equal to 1. This is very important. Again, for theory. Binomial distribution is known as biparametric distribution. Okay. As I just now told you, parameters is the characteristic. So, as it is characterized by two parameters, n and p. मतलब उसको डिफाइन करने के लिए अगर मेरे पास एक बाइनोमियल डिस्ट्रीब्यूशन है उसको उसके बारे में अगर मुझे बताना है, जैसे आपके बारे में अगर मुझे जानना है तो मुझे पहले आपका नाम मालूम होना चाहिए, राइट? तो आपका नाम जो है वो आपको डिफाइन करता है, और जैसे लोकेशन है, सपोज मैंने पूछा आप कहाँ रहते हो, तो अभी जैसे हो गया सपोज किंजल है, किंजल नाम की दो लड़कियां हो सकती हैं, तो उसको डिफाइन कैसे करें? तो किंजल जो कलकत्ता वाली है, किंजल जो चेन्नई वाली है, तो उस तरह से हम जैसे बात करते हैं उसी तरह जब हम बाइनोमियल डिस्ट्रीब्यूशन के बारे में हमको उसको डिस्क्राइब करना है, तो मेरे पास अगर मैं ये दो कैरेक्टरिस्टिक्स पैरामीटर्स डिफाइन कर देती हूँ, तो मुझे उस डिस्ट्रीब्यूशन के बारे में पता लग सकता है। वो कौन से दो पैरामीटर्स है? एक है एन, total number of trials, and p जो है probability of success. Okay, that if the values of n and p are known, then the distribution is known completely. The mean of the binomial distribution is given by mu is equal to n and p. तो अभी ये biparametric, which are the ones? This is n and p. Okay, ये concept है। दूसरा है mean, mean is given by n into p. थर्ड आता है variance, variance is given by npq. Okay, variance is given by npq. यहाँ लिखते हैं, यहाँ जगह ज्यादा है। Okay, so np, so by parametric, then mean is given by n into p, which is also equal to n into 1 minus q. Okay, then you have variance, variance is equal to sigma square, which is given by npq. What is the relation between mean and variance? Mean is always greater than variance for a binomial distribution. Why is it so? यहाँ तो p ज्यादा q ज्यादा है, but because q is a fraction, okay, so mean will be bigger than the so this is first important thing, second important thing, third important thing, fourth. This is also a theory question. Okay, they will ask you whether mean is greater or variance is greater, or they equal. Okay, so this. Now, important thing is for mode, for calculation of mode. Let's change the color. Now, for calculating mode, what I have to do is I have to calculate n plus 1 into p. Okay. Okay. Once I calculate n plus 1 into p, it may be a integer, okay, or not an integer. If n plus 1 into p is an integer, then there will be two modes. If n plus 1 into p is an integer, then there will be two modes. One is n plus 1 into p, that is 1. And the second is n plus 1 into p minus 1. Okay. So, these are the two modes. When n plus 1 into p is not an integer, then you have to take the integer part of n plus 1 into p. Okay, then you have to take an integer part and n plus 1 into p. Okay, here it is written. Mode of binomial distribution, n plus 1 into p. So if it is an integer, you will have two modes, n plus 1 into p and n plus 1 into p minus 1. If it is not an integer, n plus 1 into p, you take the largest integer part. So like suppose if you get 3.5, then you will take mode as equal to 3. No rounding up, you'll just take the integer part. Okay. There is one important thing also written over here. This. Variance of x attains its maximum value at p is equal to q is equal to 0.5 and this maximum value is n equal to 4. Okay. So variance maxima you will get when p is equal to q is equal to 0.5. Okay. Now let us see what is the value of variance n into p into q. So this is equal to n into p square because p is equal to q and p square. Okay. And when is that? That is when it is equal to 0.5. So this is equal to n into 0.5 square. How much is 0.5 square? N into 0.25. Now this can be written as fraction as n into 1 upon 4. 0.25 can be written as 1 upon 4. So n upon 4. Okay. So variance maxima is equal to n upon 4. Okay. Yes, very good. Anuj has got the answer. Very good. Now let us talk about skewness of the binomial distribution. इससे पहले भी जब हमने स्क्यूनेस की बात की थी तो बताया था कि वो असिमेट्रिक के बारे में बात करता है किसी भी प्रोबेबिलिटी डिस्ट्रीब्यूशन के और बाइनोमियल का जो स्क्यूनेस है वो किससे डिफाइन होगा एन और पी से अब व्हाट इज द इफेक्ट ऑफ एन ऑन द स्क्यूनेस ऑफ अ बाइनोमियल डिस्ट्रीब्यूशन एज द नंबर ऑफ ट्रायल्स इंक्रीजेस जैसे एन की वैल्यू हमारी बढ़ती है बाइनोमियल डिस्ट्रीब्यूशन बिकम्स मोर सिमेट्रिक ठीक है मतलब ये जो है ये हमारा ऐसा होने लगता है ठीक है when n is small the distribution may be highly skewed especially if p is far from 0.5 however as n increases the distribution becomes more bell shaped इस तरह से दिखने लग जाता है and symmetry as the limit as n approaches infinity the binomial distribution approaches a normal distribution which is perfectly symmetric okay ये भी एक बहुत important theory question है so like they will give you they will ask you when will the binomial approach normal distribution when will that happen when n approaches infinity okay effect of p on skewness the skewness of a binomial distribution is influenced by the probability of the success when p is 0.5 the distribution is symmetric अभी हमने देखा ना p 0.5 होगा तो q भी 0.5 होगा okay as p deviates from 0.5 either towards 0 or 1 the distribution becomes more skewed when p is close to 0 or 1 the distribution tends to be more skewed okay larger values of n tend to make the binomial distribution more symmetric. Values of p closer to 0.5 results in more symmetry. Okay? तो अगर आपसे पूछे कि किस वैल्यू ऑफ p के लिए बाइनोमियल डिस्ट्रीब्यूशन सिमेट्रिक होगा तो जहां 0.5 जो होगा उसके लिए सिमेट्रिक होगा. Okay, so let us see these questions. जो भी मैं आपको पहले बता रही हूँ क्योंकि आगे क्वेश्चंस उस तरह के हैं इसलिए हम उनको वो कॉन्सेप्ट को हम लोग समझ रहे हैं. An example of biparametric discrete probability distribution biparametric भी है और discrete भी है तो वो binomial है a binomial distribution is never symmetrical never negatively symmetrical so what we know binomial is positively skewed so never symmetrical होगा क्या नहीं जब 0.5 होगा तो symmetrical होगा so this is not the answer Never positively skewed. Obviously, we know it is sometimes it is positively skewed. Never negatively skewed, and symmetrical when p is equal to 0.5. Okay, so this is the case. So this is the correct answer. Okay, तो इसलिए स्क्यूनेस के बारे में क्यों बताया, क्योंकि क्वेश्चन है ऐसा, वहां बुक में नहीं दिया, लेकिन अगर हमें आंसर में समझ के करना है तो दिस इज द concept. The mean of a binomial distribution, I know mean is given by what? Mean is equal to n into p. Is always more than its variance, always less than its variance, always equal to its variance, always equal to standard deviation. We know mean is always greater than the variance. Okay. This is np, this is npq. अगर ये np निकाल दो तो यहाँ 1 है और यहाँ q है. q जो है वो फ्रैक्शन है, तो फ्रैक्शन जो है वो हरदम 1 से कम होगा, इसीलिए ये. ओके, राइट. मीन ऑफ अ बायनोमियल डिस्ट्रीब्यूशन इज गिवन बाय n into p. Okay, not both, not none of these. Okay, n into p. So if you are understood till now, please put in the chat box quickly. Yes, Anushka correct, Anuj correct. Yes. All the others, I hope you're following, I hope you're understanding. अगर आपको समझ में आ रहा है तो चैट बॉक्स में हाँ लिख दीजिए, तो मुझे समझ में आएगा कि ये आपको अगर कोई भी अड़चन है तो भी आप डाल सकते हैं वहां पे. The mean of a binomial distribution with parameters n and p is given by, okay. Now see, the mean of a binomial distribution. Okay, this is clearly n into p, variance of a binomial parameter distribution. Okay, जैसे ये लिखा है ना, तुरंत हम यहाँ पे उसके बाजू में हम अपना आंसर लिख देते हैं और फिर देखते हैं, क्योंकि कभी कभी जो है ना आंसर थोड़ा सा ट्विस्ट करके रहता है. तो मुझे अपना आंसर एकदम क्लियर मालूम चाहिए. तो एन पी क्यू. नाउ दिस इज एन इंटू पी स्क्वायर. अगर मैं सिंप्लीफाई भी करने की कोशिश करती हूँ तो 1 माइनस पी इज वॉट? क्यू. तो दिस इज एन पी स्क्वायर क्यू. Is it the correct answer? No. So this goes away. Square root of np. So this is npq. ये square root है. What is this? This is the standard deviation. This is not the variance. Okay, they are asking about the variance. Also be careful what they are asking for. Nq 1 minus q. What is n minus q? 1 minus q. This is p. And nqp, which is equal to npq. So this is the correct answer. Okay. Yes, Anush, crystal clear. Anushka, yes, nice explanation. Sakshi, concepts are clear. No doubts, Kinjal. Yes, very nice. Omkar is saying your teaching methods are good for understanding anything difficult part of this paper. Salute to ma'am. Oh, thank you, Omkar. Thank you so much. Renuka understood. Yes. It really helps, that my teaching is helping all of you. So that's a really good thing to know. आपको समझ में आ रहा है ये सुन के, ये पढ़ के बहुत अच्छा लगता है. Now for a binomial distribution, mean and mode. Okay. What is the binomial distribution mean? Mean is n into p. What is the mode? Mode, you have to calculate first n plus 1 into p. Okay. Then what will happen? Either it is an integer or not an integer. If it is an integer, what will be the value? It will be n plus 1 into p and then n plus 1 into p minus 1. Not an integer, then take the integer part. Okay. So for a binomial distribution, mean and mode are never equal. Are equal when q is equal to 0.5, are always equal, do not always exist. Okay. Now, see, I don't know. Okay, I don't know. Now what is this? This is q is 0.5. So let me try to see what happens when I put q as 0.5. Okay. So mean will be what? 0.5 into n. Okay. Mean, because I don't know n. So If Q is 0.5, that means, which implies P is also 0.5, right? Because P plus Q should be equal to 1. Okay. Then, what will be the mode? Mode will be n plus 1 into 0.5. N plus 1 into 0.5 will be the mode. So this will be 0.5 n plus 0.5. Okay, this is 0.5 n plus 0.5. Okay, so I have to take, now this is a fraction, so I have to take only this, the integer part. What is the mean? Mean is also 0.5 n. This is also 0.5 n. So for 15th, C is the correct answer. The mean of a binomial distribution is always more than its variance. Yes, we know it's always more than its variance. Okay, so see, the same question is being, sometimes the words are different, but the meaning is the same. Okay. For a binomial distribution, there may be one mode, two modes, multi-modes, A or B. Okay. Now, very important. ये वाला क्वेश्चन इंपॉर्टेंट है. मल्टी मोड्स क्या होता है? एक हो, दो से ज्यादा हो. बाइनोमियल में दो से ज्यादा होते हैं क्या? नहीं. तो आंसर क्या है? आंसर हमें जो सबसे करीबी आंसर है उसको टिक करना है. वन मोड होता है क्या? हाँ. दो मोड होता है क्या? हो सकते हैं. उससे ज्यादा हो सकते हैं क्या? नहीं. तो डी जो है वो दैट इज द मोर करेक्ट आंसर. ए और बी, मतलब either you can have a single mode or you can have two modes. Okay, so D will be the correct answer. The maximum value of the variance of a binomial distribution with parameters n and p is given by. Okay, so we did that. This is n by 4. Ashinka is also saying crystal clear. Yes. Anushka is saying it's good we are able to solve the MCQ. Yes. See, sometimes what happens, because there is such a lot of syllabus, what we do is, अच्छा बाबा पीछे आंसर ये लिखा है क्या, मैं इसको याद कर लेता हूँ. आप ऐसे करते जाओगे फिर जो थ्योरी पार्ट है ना वो इतना बड़ा हो जाता है स्टैटिस्टिक्स में, क्योंकि आप बहुत सारी चीजें याद करने की कोशिश करते हो जो पॉसिबल नहीं होता है. क्योंकि क्या होता है, वहां वर्डिंग्स भी अलग आ सकती है. आपका कॉन्सेप्ट जो है वो क्लियर होना चाहिए. आपको समझना चाहिए कि इसको आप किसी भी शब्द में आप बदल दीजिए. हम्म तो आपको समझ में आना चाहिए. जैसे अगर करेले को कितना भी शहद में डालो आपको समझ में आ जाएगा ना वो करेला है. उसी तरह कॉन्सेप्ट भी एकदम क्लियर होने चाहिए. आप कोई आपको कितना भी कंफ्यूज करने की कोशिश करे, आप बोलोगे मुझे आंसर मालूम है, आप उसको कितना भी घोल दो चीनी में शहद में, मैं समझ जाऊंगा कि आपने करेले के बारे में ही पूछा है. ठीक है ना? ओके. सो now let us do certain sums also. Okay. So we know this formula. Hmm? We already know this formula. Now let us go to the sum. So we are doing set B question. Let me see if I have opened this. Just let me check the page. 6.43 page number. Let you know. 16 rather, not 6, 16. Okay, yes. The fourth question in this. If a binomial variate with parameters 15 and 1 by 3. देखिए, they've just given you parameters. So it is also represented by n, comma, p. Okay. Sometimes they may even give you like this, they will give you What does this mean? It means n is equal to 15, p is equal to 1 by 3. Okay. If I have p is equal to 1 by 3, q will be equal to how much? 1 minus 1 by 3, which is equal to 2 by 3. Okay. Now, what are they saying? What is the value of mode? Okay, they are asking you what is the value of mode. Now, for that, what is the step? N plus 1 into p. First, I must find out n plus 1 into p. What is n? N is 15. 15 plus 1 into p. P is how much? 1 by 3. Now, remember, you have to follow the BODMAS. So, this is 15 plus 1. Okay, so this is 15 plus 1 is how much? 16. So this is 16 upon 3. So how much is this? 5.33. 5.33. So not an integer. Not an integer. So mode will be equal to integer part. So what is the integer part? 5.33 का integer part क्या है? 5. So 5 is the correct answer. Okay, that is why B is the correct answer. See, you may feel this one. This is also not true, not true. 5 and 6 also not true. Why? Because we've got n plus 1 into p to be not an integer. So there will be a single mode. Next question is, what is the mode of the distribution for which mean and standard deviation are given? Okay, so mean of a binomial distribution is given by n into p. Standard deviation of a binomial distribution is given by square root of n p q. Now how much is this? 10. 10 is equal to n into p. Standard deviation is given as root 5. Root 5 is equal to square root of n p q. Okay. Squaring both sides. You have 5 is equal to NPQ. Okay. So, now N into P. ये जो N into P है ना, उसकी जगह पे N और P है ना? N और P क्या है? Equal to 10 है. Okay, so I'm going to substitute. So 5 is equal to 10 into Q. So Q is equal to 5 by 10, which is equal to 1 by 2. Okay, so I have got this. Now I know mean is equal to n into p is equal to 10. Okay. Now, if my q is half, my p will be equal to how much? 1 minus q, which is equal to 1 minus half, which is equal to half. Now, n into p is equal to 10. N I don't know. P I know is half, which is equal to 10. So, n will be equal to cross multiplying. I take the 2 to that side. It is 10 into 2, which is equal to 20. Okay. So, now I have to calculate mode. What do? I first find out n plus 1 into p. How much is my n? 20 plus 1. And how much is my p? 1 half. 20 plus 1 is 21. 21 upon 2. 21 upon 2 is equal to 10.5. Okay. So, which is 10, 10.5, which is not an integer. So, mode will be equal to integer part, which is equal to 10. Okay. So, स्टैंडर्ड डिविएशन एनपीक्यू, स्क्वायर रूट ऑफ एनपीक्यू होता है। अनुज, वरायंस एनपीक्यू होता है, स्टैंडर्ड डिविएशन स्क्वायर रूट ऑफ, सबको वो रिलेशन मालूम है ना, वरायंस और स्टैंडर्ड डिविएशन? स्टैंडर्ड डिविएशन इज स्क्वायर रूट ऑफ वरायंस, है ना, ये मत भूलिएगा, या वरायंस इज इक्वल टू स्टैंडर्ड डिविएशन का स्क्वायर। ओके, yes, so now everybody has got the answer. Yeah. Okay, ब्रेक ले ले 5 मिनट का। चिराग, yes, okay, thank you. Welcome back. So we have talked about what is the mean, what is the variance, what is the standard deviation of a binomial distribution. We found out the variance is maximum at n at the value n upon 4 when p and q are equal to 0.5. Okay. Then there is additive property of binomial distribution. We have talked about an additive properties in mathematics also. No? So similarly, we have over here. So suppose I have one binomial distribution x, which is defined by b n n1 p. Okay. And then I have another binomial distribution which is defined by n2 p. Okay. So the p is same, and then I have n1 and n2. So I have two different distributions. And what does the additive property say that you can add this up. So n plus y will be equal to n1 plus n2 into and p. These the parameters will be n1 plus n2, and p is the same as for the earlier two distributions. Okay. So let us try to solve the problem with it. If x and y are two independent binomial variables with parameters 6.5 and 4.5 respectively. So I have one which, okay, x is defined by 6.5. Okay, so 6 is n and half is p. And I have another which is defined by 4.5. Okay. Then what is p of x plus y greater than or equal to 1? Always remember this. We have done it in statistics. Greater than or equal to 1 is equal to, like you remember this formula? P z greater than or equal to 1 is 1 minus p z less than 1. So which is equal to 1 minus p of x plus y less than 1. Okay. Now what does this mean? Now we know from the additive property, from this property, I know that x plus y, I can do that. Okay, so x plus y is b n plus n1 plus n2 into p. Well, what is n1? This is my n1. What is half? Half is my p. What is 4? 4 is my n2. What is half? Half is p. So I have b. B is equal to n1 plus n2 into and p. So B is 6 plus 4 and P is how much? Half, which is equal to B 10 and half. Now, what is P? X plus Y greater than or equal to 1 will be equal to 1 minus P x plus Y less than or equal to 1. Less than 1, not equal to, less than 1. Now, for x plus y less than 1, what is the discrete number which is less than 1? Only 0. What is the discrete number which is less than 1? Only 0. So, what am I going to do? This is going to be equal to 1 minus p of 0. Okay, this is going to be 1 minus p of 0. So, now p of 0. P of 0 we have to find. Okay. Now, what is the formula? P is equal to NCX. Px is NCX, P raised to X, Q raised to N minus X. Now here, what is my N? N is 10. Okay. 6 plus 4, N is 10. What is my P? P is half. What is my Q? Q is half. Why? Because 1 minus half is half. So P of 0, and what is X? X is 0. Right? We want to find this. P of 0 is 10C0. P is half. Half raised to 0. Q is also half. Half raised to 10 minus 0. 10C0 is how much? 1. Okay. 1 half raised to 0 is 1. And 1 half raised to 10 minus 0 is 1 half raised to 10. So this is equal to 1 half raised to 10. 2 raised to 10 is 1024. So this is equal to 1 upon 1024. Now, what we need is P of x plus y greater than or equal to 1 is equal to 1 minus P of 0. This is equal to 1 minus 1 upon 1024, which is equal to 1023 upon 1024. Okay, so this will be the answer. Have you all understood? Yes. Good. Kritika, Anushka, Avni. Yes. Those watching on YouTube also, just make sure that you are understanding, and don't forget to press the like button. That helps the institute also to understand that you are understanding the sessions. The next question. Yes, crystal clear? Very nice. Assuming the coin to be unbiased, what is the probability of getting 4 heads? At least 4 heads, at most 4 heads. What is the probability of getting 4 heads? At least 4 heads means this is simple. Here, what is n? N is 10. What is x? X is 4. 4 heads. Okay. Coin. For a coin, P is how much? Half. Q is also half. Okay. Right? Probability of getting a head. This is probability of getting a head is half. So, and P is half. Q is half. Okay. At least 4 heads means what? It will be 1 minus P of 0, P of 1 plus P of 2 plus P of 3. Okay, I have to calculate these 4 and then subtract it from 1 will give me the probability of getting at least 4 heads. At most 4 heads, this I can get. At most 4 heads is P of 1, 2 and 3 plus P of 0. Okay, why? Because I can have no heads, that is also less than at most 3 heads, 1 head, 2 head or 3 head. Okay, so this is the way you have to tackle the sums. Now let us go into the actual calculations. Okay, 4 heads. So first is no issue. So I have 10C4 half raised to 4 and 1 half raised to 10 minus 4, which is equal to 10C4 half raised to 10. Half raised to 10 I know is 1024. So what I need to calculate is 10C4. Now 10C4. 10C4 is equal to 10 factorial upon 6 factorial into 4 factorial. You know 10 minus 4 is 6. So how much is this? 10 into 9 into 8 into 7. 6 factorial is cancelled. 4 factorial I know is 24. Okay. So how much will that be? This is 24. 8 3 3 3. So this is 210. Okay. So 10C4 is 210 upon 2 raised to 10 I know is 1024. Okay. Now let us go to at least 4 heads. At least 4 heads is, I will P of 0, which is equal to 10 C0 half raised to 10, because there is no need to write half raised to 0 and then half raised to 10 minus 0. Okay. 10 C0 I know is 1. So this is 1 upon 10. 2, 4. P of 1, 10C1 half raised to 10. Okay. NC1, NC1 we know is N. Okay, so this is 10 into 10 upon 1024. P of 2 is equal to 10C2 half raised to 10. 10C2 is, this is 8. So 10 into 9 upon 2. So into 1024. So this is 45. Okay, 45 upon 1024. P of 3 is 10C3 half raised to 10. So this is equal to 10 into 9 into 8 upon 24 into 1 upon 1024. So this is 4, 3, 8 3s are 24 and then 3. So this is 30 upon no, not 24. This is 3 factorial. So you'll get a 6 here, not 24. Sorry about that. So this is 6. So this is 4 and then this is 3. This 3 cancels with this. Okay. So this is 120 upon 1024. Okay. So now I have P at least 4 heads. Okay. So it's giving me P of at least 4 heads is equal to 1 minus, in the bracket I have 1 upon 1024, 10 upon 1024 plus 45 upon 1024 plus 120 upon 1024. Okay. I have not done simplified because it becomes easier. So this is 1024 minus 1 plus 10, 11, 11. This is 131, 131 plus 45, 131 plus 45, 176. Okay. Minus 176 upon 1024. This is equal to 848 upon 1024 is the answer. So at least 4 heads, I am getting this answer. And how much is this? This portion 176 upon 1024. So what do they want? At most 3 heads is 176 upon 1024. What we calculated, that is going to be at least 3 heads. Okay. Anil, weightage of this chapter is 25 to 30% along with probability. Okay. So have you all understood this? Okay. So you can simplify also. If there is that is a possibility, you can go ahead and simplify. Yeah. Yeah, I think it can be easily divided by 8. Okay. So clear? Yeah, very good. Very good. I hope everybody is understood. Even on YouTube, everybody is understanding. Now let us go to the next. If 15 dates are selected at random, what is the probability of getting 2 Sundays? Okay, what is the probability of getting 2 Sundays? N is 15. P is how much? What is P? P is probability of getting Sunday. Probability of getting a Sunday is how much? 1 upon 7, because there are 7 days in a week. So what is the probability of getting a Sunday is 1 upon 7. What is my X? X is 2, because what do I want? I want 2 Sundays. So what is the definition of success? Success is getting a Sunday. So P is of getting a Sunday is 1 by 7. So I have x is equal to 2, that is getting 2 Sundays. 2 Sundays within the 15 days period that I have selected is equal to 15C2 15C2, P is 1 by 7 raised to 2. If P is 7, then Q is equal to 1 minus P, which is equal to 1 minus 1 upon 7, which is equal to 6 upon 7. So this is equal to 6 upon 7 raised to 15 minus 2. So 15 is 15 into 14 upon 2. This is equal to 1 upon 7 square, 6 upon 7 raised to 13. Okay. So this is equal to 7. So 105, 6 raised to 13 upon 7 raised to 15. Okay. So this will be the answer. Is that clear? So once you read the question, you need to understand that this can be solved using the probability distributions, and then you are going to use the binomial distribution, because now you have the concept of success and failure. Either the given day is a Sunday or not. The next example we are seeing is 16.4. Yes, everybody understood? Find the probability of a success for the binomial distribution satisfying the following relation. Okay. And this is an interesting one. Parameter n as 6. Okay. So I have n equal to 6, that is given. And I have been given 4p4 is equal to p of 2. So we want to find the probability of a success. So what do we need to find? We need to find p. Now 4. Okay, let me first let me solve it separately. P4 is equal to 6C4 P raised to 4 Q raised to 6 minus 4, which is equal to 6C4 P raised to 4 Q raised to 2. Okay. Now how much is 6C4? 6 into 5 upon 24. 6 4 is a, okay. So just a minute. This is 6 into 5, 4 factorial gone, upon 2, and P raised to 4, Q raised to 2. So this is 3. So this is equal to 15 P raised to 4 Q square. Okay. Now P2 is equal to 6C2 P raised to 2 Q raised to 4. 6C2 is 6 into 5 upon 2 with P square Q raised to 4, which is again equal to 15 P square Q raised to 4. Okay. This we know. NCR is equal to NC n minus R. So 6C4 will obviously be equal to 6C2. Okay. Now let us put it in the equation 4px. So 4 into 15 p raised to 4 q square is equal to 15 p square q raised to 4. Okay. Now this 15 is going to get cancelled. This is p raised to 4 q square. So I will use the concept of this thing, indices. So I will have 4 into p raised to 4 upon p square. This p square I'm bringing down is equal to q raised to 4 upon q square. I've taken this over here. Okay. So this is what 2 and 4. So this becomes 4p square is equal to q square. 4 minus 2 is 2. Taking square roots on both sides, what will happen? 4p square will become 2p. Square root of 4 is 2. P square, square root is, and this is q. Now I know that 1 plus p is equal, 1 q plus p is equal to 1. So how much is q? 1 minus p. So instead of q, I can write 1 minus p. So I have 2p is equal to 1 minus p. Now I take the p to this side. I have 2p plus p is equal to 1 because I have taken this minus p to this side. So 3p is equal to 1 or p is equal to 1 by 3. This is the answer. What is the probability of success? It is 1 by 3. Yes, please quickly put in the chat box whether or not you've understood. Okay. And those watching on YouTube, please press the like button. Okay, find the normal distribution for which mean and standard deviation are 6 and 2 respectively. Okay. Once you've understood one standard probability distribution, becomes easier for you to follow the others. So let us see. Now find the binomial distribution. Okay. So what happens here is you will get the answers in terms of n, x, p. Okay. So that we have to see. Okay. Quickly put in the chat box whether or not you've understood. Find the binomial distribution for which mean and standard deviations are 6 and 2 respectively. Now I know mean to be equal to n into p for a binomial distribution, and this is given to me as 6. Standard deviation, which is equal to square root of variance, which is equal to square root of npq, is given to me as 2. Okay. So squaring both sides, I have npq to be equal to 4. Okay. Now, variance, which is equal to 4, is equal to np into q. Okay. Now, instead of np, what can I put? I can put 6q. So, 4 is equal to 6q. So, q is equal to 4 upon 6, which is equal to 2 by 3. So, how much is p? P is equal to 1 minus q. 1 minus 2 by 3, which is equal to 1 by 3. Okay. So means what? So what is my probability distribution? Is equal to, the distribution is equal to ncx p raised to x q raised to n minus x. Now n is how much? No, now we have calculated P. So mean, which is equal to N into P, so which is equal to 6 is equal to N, I don't know, P is 1 by 3. So N is equal to 6 into 3, which is equal to 18. So N is 18. So 18 CX. P is how much? 1 by 3 raised to X. Q is 2 by 3 raised to 18 minus X is the binomial distribution. Okay. Any other questions? I hope you've understood. Yes, Anush, correct. Kritika, yes. Very good, very good. Now, what is known as fitting of binomial distribution? Okay. So, in order to fit a theoretical probability distribution to an observed frequency distribution, it is necessary to estimate the parameters. Okay. So, N and P. How do we do that? We do that using a method of moments. Okay. So, these are all theory questions that can be asked. This comprises equating P moments of a probability distribution to P moments of the observed frequency distribution. What does this mean is I make the calculation, I do the calculations, and then I check whether or not they are matching with the observed data. Okay, and then so the question 19 question, the method used to applying for fitting a binomial distribution is method of moments. Okay. Then how do I do that? I just explain the concept. Why? Because the whole thing will not be asked to you. So suppose this is my observed frequency distribution. Then 0, 1, 2, 3, 4, 5, and then they are saying n is equal to 5. Okay. Now, now first we must find p cap, okay, which is equal to x bar, that is a mean upon n. For that I need to find x bar. X bar is how much? Summation fx upon summation f. Remember in the chapter on mean median mode we have done. So this is 0. How much is this? 0 into 3 plus 1 into 6 plus 2 into 10 plus 3 into 8 plus 4 into 3 plus 5 into 2 upon summation f. This is equal to 3 plus 6 plus 10 plus 8 plus 3 plus 2. Okay, so this is giving me 2.25. So x bar I get as 2.25. And then I find p cap. P cap is what? X bar upon n. X bar is 2.25. N is how much? 5. So this is equal to 4.5. Okay, so I get 2.25 P cap. Okay. So how much do I get here? Yes? Okay. You audible? Yeah. I don't know. Maybe by mistake somebody has. Okay. So now what happens is once that oh no, this is not 4.5. Oh, okay. 0.45. So 0.45. If P cap is this much, Q cap will be how much? 1 minus 0.45, which is equal to 0.55. Okay. Now I use these values and then I find this. So this is how you got pi c x. Now here they have used 0.4 and they have rounded it off to 0.4 and then here 0.6. Okay, so 0.4 raised to x, 0.6 raised to 5 minus x. And using that, then I find now n, this capital N is 32. Where does this 32 come from? This comes from addition, summation fx. Okay, so this is equal to summation fx, which is equal to 32. Okay, and then you make this, you do all these calculation. This was, for the 12th standard or BCom students who have taken maths, or statistics students. So you calculated this. Now I've just put in over here. Once you've done this calculation, the main thing here was understanding how we calculated p cap. So once you've done that, you can find out. Now here, see, you can see 2.49, this is 3, observed is 3. This is calculated as 8, observed is 6. Okay, and so on and so forth. Always remember, this total should always match. Only the distribution will change, but the total will match. So this is how you find the expected frequency distribution. Now let us go to 16.8. So some word problems are there. अबे क्वेश्चन में दिया है n5 है करके, क्योंकि जो 0 है ना, वो तो है, मतलब एक्सपेरिमेंट ही नहीं हो रहा है. We don't consider that case. उन्होंने दिया है n is equal to 5. Now an experiment succeeds thrice as after it fails. मतलब succeed thrice as after it fails. As after बहुत important word है. As after means what? एक बार fail हुआ, उसके बाद क्या हुआ? 3 times success हुआ. Okay. Once you fail and then after that you get 3 successes. Means what? How many trials are there? Trials are how many? 1 plus 3. This is 4. This is the most important word in this question. Okay. As after it fails. Sometimes they will say twice as much as it fails. So as much, here it is saying as after it fails. Means what? Already the failure trial has been done. After that you are doing 3 more. Okay, so trials is 4. If the experiment is repeated 5 times, what is the probability of having no success at all? Okay, so I have an experiment succeeds. So P, what is the value of P? 3 upon 4. Q will be obviously 1 minus 3 upon 4, which is equal to 1 by 4. Now, if the experiment is repeated 5 times, means what? N is 5, P is 3 by 4, Q is equal to 1 by 4. What is the probability of having no success at all? So P of 0 is equal to 5C0, 3 upon 4 raised to 0 and 1 upon 4 raised to 5. 5C0 is 1, 3 upon 4 raised to 0 is also 1 and 1 upon 4 raised to 5 is 1 upon, so 4, 6, 4, 4, 16, 16, 64, 16 into 16, 256, 256 into 4, this is 1024. So answer is 1 upon 1024. Okay. This example from set C we are taking. X is a binomial variable such that x is equal to 2 is equal to p, x is equal to 3 and mean of x is known to be 10 by 3. Okay. So mean is equal to 10 by 3. I know mean is equal to n into p. So n into p is 10 by 3. what would be the probability that x assumes at most value 2? Okay. Now see what happens is at most value 2 means what? X can take the value. So I need to find P of 0 plus P of 1 plus P of 2. Okay. Now, first I need to find out all the values N and P. Now, P of X of 2. So 10 is equal to 3 NP. Now, P X of 2 is equal to NC2 P raised to 2 Q raised to N minus 2. Okay. This is equal to n factorial upon n minus 2 factorial into 2 factorial, which is 2, p square q raised to n minus 2. Now, how can I write this? N into n minus 1 into n minus 2 factorial upon n minus 2 factorial into 2. So, this n minus 2 get cancelled. This is the answer for p x is equal to 2, which is giving me how much? N into n minus 1. This is already there. P square q raised to n minus 2. N minus 1 upon 2 into p square q raised to n minus 2. This is equal to p of x is equal to 2. Now p of x is equal to 3 is equal to nc3 p raised to 3 q raised to n minus 3. Now nc3 again will be equal to n into n minus 1 into n minus 2 upon 6, right? nc3 will get cancelled and then pq q raised to n minus 3. Okay. Now I will put it in the equation which is saying that 2 times p of 2 will be p of 3. Okay. Now let me do that. Sorry about that. Okay. Now 2 times, how much is P2? Is n into n minus 1 upon 2 p square q raised to n minus 2. 2 into n minus 1 upon 2 p square q raised to n minus 2. This is equal to how much? How much is P3? N into n minus 1 into n minus 2 upon 6 p raised to 3 q raised to n minus 3. This 2 will get cancelled, this n will get cancelled, this n minus 1 will get cancelled. Okay, what is remaining right now is p square q raised to n minus 2 is equal to n minus 2 upon 6 p cube q raised to n minus 3. Now here also, okay, pay attention to this. This is 2 over here. This is 3 over here. Okay, so I will, you can do it simultaneously. Both the steps you can do simultaneously. I'm first talking only about P. So this 2 and this 3, how can I write this? P3 can be written as P square into P. Okay, so this 2 P square and this P square get cancelled. So what will I be left with? I will be left with, I'm giving you the very small steps so that you can build upon it. Is equal to n minus 2 upon 6. The P3, this P square gets cancelled. So what is remaining here is P q raised to n minus 3. Okay. Now, what happens here is, again, what will happen? Now this q raised to n minus 2, and if I take this q raised to n minus 3 here in the denominator, q raised to n minus 3. Remember, a raised to m upon a raised to n is equal to a raised to m minus n. So I'm going to use this logic, and what am I going to get? Q raised to n minus 2 minus of n minus 3. Just be careful that you put in the bracket, So if I open the bracket, this is equal to n minus 2 minus n plus 3. So this n and n get cancelled. Minus 3 plus minus 2 plus 3. So what is the answer? It is q. Okay. So what I have done, I have taken this to this side and what I solve it. How much do I get? I get q. So q is equal to n minus 2 upon 6 into p. Okay. Now q is equal to, I multiply this. This is equal to n into p minus 2 upon 6. What is the value of n into p? N into p is already given to me as 10 by 3. Okay. So q, I take this here. So 6q, np is 10 by 3 minus 2. 10 by 3 minus 2. The 6 I've already taken to this side. So how much is this? 3 2s are 6. This is equal to 4 upon 3. 10 minus 6, 4 upon 3, 6q. So q is equal to how much? 4 upon 18, which is 2s are 9s are 2 by 9. What went wrong? Then I will get p as equal to 7 upon 9, n into p as 10 by 3. So if I get this, so n will be equal to 10 upon 3 into 9 upon 7. Oh no, something is wrong. So I think some addition, subtraction I've done. Just let me check. So here I have got n into n plus 1 upon 2, which gets cancelled, p square q raised to n. And this is n into n minus 1, n p3, n minus 3. This is correct. So 2 times, is it 2 times? Yes, 2 times p2 is equal to 2 times p square and q raised to n minus 2, n into n minus 1 into n upon 6. This is correct. So this is p is equal to, so p, okay, do I have a page here? Yeah. Just let me see here. From here I can redo it. Oh yes. This is giving me q. So q is equal to, yes, sorry about this. When I solve this, this is giving me q is equal to n minus 2 into p is equal to n into n minus 1. That has got cancelled. N into n minus 1 got cancelled. And what is that? N minus 2 upon 6 into p. N into n minus, yeah, into p. And this should get me the value for p. And then I must be able to find the value for q. And q I will find out. Then I must get the value for n. Then n. So I have, just let me see, n into n minus 1 into n minus 2. This, let me check, nc3 is equal to n factorial upon n minus 3 factorial into 6. Okay, n into n minus 1 into n minus 2. This n minus 1 gets cancelled. Yes. Okay, just let me. So q is equal to np minus 2p. Oh, yes, upon 6. Now I've got it. I forgot to multiply the p here. So this was the simplified form. When I simplified p, 2p2 is equal to p3. Okay, simplification. So I forgot to multiply the p with the 2. So now what I have here is 10. So I have 6q is equal to np minus 2p. Okay. Now np I know is 10 upon 3 minus 2p. Okay, 6q, which is equal to how much? 10 minus 6p upon 3 is equal to 6q. So 18 was correct. So, not p, q. Yes. So this is 6q. Okay, so I have 6q into 3 is equal to 10 minus 6p. So this is 18q is equal to 10 minus 6. And what is p? P is 1 minus q. P is 1 minus q. So this is equal to 18q minus 10 is equal to 10 minus 6, minus into minus plus, so plus 6q. Okay. So this 6q I take to this side. So 18q minus 6q, 10 minus 6 is 4. So how much is this? 12q is equal to 4. Q is equal to 4 upon 12. So Q is equal to 1 by 3. If Q is equal to 1 by 3, P is equal to 2 by 3. Okay, 1 minus P, 1 minus Q. Okay. Now I know N into P is equal to 10 by 3. That is given to me. Now N into 2 by 3 is equal to 10 by 3. So this 3 gets cancelled. N is equal to 5. Okay, so what is the, an experiment is repeated 5 times. What is the probability? No, what is the probability that X assumes at the most the value 2? Okay. So what will I now have to do? Now I have my N. Now I have the same. So N is equal to 5. P is equal to 2 by 3. No? Yes. P is equal to 2 by 3. Q is equal to 1 by 3. So I will find P for 0, P for 1 plus P for 2 at most 2, right? At most 2. So this I have to put. So pi c 0, P raised to 0. So the, and I have 1 by 3 raised to 5 plus pi c 2, 2 by 3 into 1 by 3 raised to, this is 1. 1 plus pi c 2, 2 by 3 raised to 2 and 1 by 3 raised to 3. Okay, so you have to solve this and find out the value. Is that clear? Mm-hmm. See, I would recommend that you do set A and B. Okay, set C only if you want to go deep into it. I usually want you to, just for the understanding sake, that you should be able to understand this. Okay, so you can easily solve this and get the answer. Is that clear? Any other doubt you have? Okay, just remember, here this is the correct, because I forgot to multiply this 2 with p, therefore this answer is not. See, np minus 2. Okay, so here I made that mistake. Other than that, then you can follow from here. Okay, so you should be able to get the answer. Is that clear? Yes, I think that's all for today. I hope you had a nice time with binomial. Next time we will be doing Poisson and normal distribution. Okay, thank you all. Have a great day ahead. Thank you. Yes, please.